Okay, the last type of problem that you're going to see over and over on this packet is quadratics within geometry, so used to represent geometric relationships. And you'll notice, again, I'm going to read through the whole problem so that we know kind of what we're looking for, but this particular problem, I'm going to look at 19, says the base of a triangle is 1 more than 4 times the height. So it's giving me a relationship between the base and the height of the triangle. And then it asks me to write a polynomial in standard form that represents the area of the triangle. So I know that I'm going to kind of deal with area here. Determine the dimensions, that height and base, that will give a total, again, there's area of 9 centimeters. So it looks like I'm going to create a polynomial that represents area, and then I'm going to use a specific area to find that height and the base that would calculate that area with this relationship. So off to the side, I'm going to quickly write on the ones that you'll do within this packet. We need to remember that the area of a triangle is always 1/2 the base times the height of that triangle, right? And on a triangle, again, base represents like the bottom, or in other words, where this altitude is, or where the height is creating a 90-degree angle with the side. And then remember that the area of a rectangle or a square is just length times width. So you could call it base times height, but essentially, usually we call it length times width. So those are the two formulas you're really going to need. So on here it says, again, and I'm going to draw a little picture over here to kind of try and make sense of what's going on. It might not be drawn to scale at all, but here's like a height I can look at, and there's my base down there. So it says the base of a triangle is 1 more. 1 more always means plus 1. Then 4 times the height. 4 times the height. I don't know the height, so I'm going to come down here and I'm just going to call that h. And then it tells me that the base is going to be 1 more than 4 times that height. So 4h plus 1. So there's my height and my base relationship. And again, if I want to make a polynomial for the area, then I use the area formula and those two relationships. So it looks like area is equal to 1/2 the base times the height, or the height times the base. So I'm going to put h and then 4h plus 1. It asks me to write this in standard form in the instructions, so I do need to distribute that in. So let's distribute in the 1/2 h. So the area here would be equal to 1/2 times 4 is 2h squared. 1/2 h times 1 is just 1/2 h. So this right here is in standard form, and it's a polynomial that represents the area. So now it asks me to determine those dimensions, the height and the base, that give us an area of 9, right? So if the area is 9, so I'm going to plug 9 in for the area, then we're going to figure out, well, what would the height and the base be? Now notice in my equation I have no b values, but I can determine the height so that I can then determine the base. So we're just going to solve this. Now remember, in solving quadratics, we want to set it equal to 0 first. So let's subtract the 9 to the right-hand side of the equation here at the end. And then equations are a little more challenging to factor if there's fractions involved. So to get rid of that fraction, if 2 is the denominator, let's multiply all the terms. And you can do this if you multiply every term by 2. I'm writing this kind of weird, but if we multiply every term by 2, then that keeps that equation balanced. So 2 times 0 is still 0. That would be 2 times 2h squared is 4h squared. 1/2 times 2, that's why we multiplied it by 2, just leaves h. And -9 times 2 is -18. So now we have an equation here. There's no greatest common factor, so we can go ahead and try and factor that. Maybe I should have left a little room so I could figure out my factors here. So I'm going to put it down here. I know that, oh man, sorry. I know that I'm going to break this apart and into my two factors, and the possibilities here are 4h and h, or 2h and 2h, right? Those are the factors of the first piece. And the last one is 2 and 9, 3 and 6, or 1 and 18. And they need to have a difference of 1. So if we start to match these up, it looks like, to me, if I do the 4 and the 2, that would give me 8h. and the h and the 9 would give me 9h. That has a difference of 1, so 9 minus the 8h. I'm going to pull the negative back with the 2. That allows us to put this in here, so 4h and h. The 4h, again, we want it to multiply by the negative 2, so it goes in the other parenthesis, and then we have plus 9. Now, if you're solving this, remember we would just state the solutions after that. So h would be either equal to negative 9 over 4, or h is equal to positive 2. With quadratics, we attain those two solutions, and then notice we have to make sure and decide which one makes sense. So if you look at what we're dealing with here, is h represents the height of a triangle. So the height of this triangle can't be a negative value. So this is actually an invalid solution based on the context of the problem. So we know that the height must equal 2. And we're dealing with centimeters, I believe, here. Once we know the height, we can calculate the base because of that relationship that it gave us. So we know that the base is over here, right? 4h plus 1. So 4h, which was 2, plus 1. If we have 8 plus 1, it looks like our base is going to be equal to 9 centimeters. So we've got a height and a base. Again, very common when we're setting up area that we see quadratics. So we just want to make sure that we're able to factor that and to solve. If you were setting up the polynomial and it asked you to find the maximum area, again, when it uses that word max or min, that takes us back to using that vertex instead of solving and finding the solutions. Okay?